Solving absolute value inequalities. So absolute value inequalities have two forms. The first one that we'll look at is when we have the absolute value of something is less than a number or less than or equal to a number. And we do need to have the absolute value isolated. So if it's not isolated, you would need to go through the steps to isolate it first. So for example, the absolute value of 3x minus 2 is less than 5. So the pattern for the absolute value of x is less than a, some number, is to remove the absolute value bars and write as two inequalities with an and. So the opposite of a is less than x, and x is less than a. So for ours, we'll take the 5, take the opposite of it, negative 5 is less than, and then take what's inside the absolute value bars, 3x minus 2. So we have negative 5 is less than 3x minus 2, and 3x minus 2 is less than the positive 5. Now, to solve these inequalities, we're going to solve using test values, so we'll write as equations and solve. So this becomes negative 5 equals 3x minus 2, and 3x minus 2 equals 5. We'll add 2 to both sides. This becomes 3x equals negative 3. Divide both sides by 3. This becomes x equals negative 1. The second one, we'll add 2 to both sides. Becomes 3x equals 7. Divide both sides by 3. And we get x equals 7/3. Okay, next we'll draw a number line and we'll graph our solutions. So we've got our number line. We have negative infinity on the left, positive infinity on the right. We've got negative 1 to the left. We've got positive 7/3 to the right. Negative 1 comes from this inequality, which is less than, no equal bar, so it's not included. So we use an open circle. 7/3 comes from this second inequality, which is also less than with no equal bar. So it is also not included and gets an open circle. Okay, next we'll choose test values in each of the intervals. We see 3 intervals here. And then we'll determine if the test values make the original absolute value inequality true or false. So to the left of negative 1, I'm choosing the number negative 2. You could choose any number to the left of negative 1 or less than negative 1. I'm choosing negative 2. And we want to choose a number in the interval between negative 1 and 7/3. I'm choosing 0 because it's an easy number to work with. And then we want to choose a number on the interval that's greater than 7/3. I'm choosing 3. Okay, so this is where we left off. Let's test first our negative 2 in our original. So the absolute value of 3 times the negative 2 that we're substituting in, that was our test value, minus 2, is that less than 5? So the absolute value of 3 times negative 2 is negative 6, minus 2, is that less than 5? The absolute value of negative 6 minus 2 is negative 8, is that less than 5? The absolute value of negative 8 is 8, 8 less than 5, that is false. So I will write false on that interval. Let's test the 0. Let's substitute 0 in for x. The absolute value of 3 times 0 minus 2, is that less than 5? Absolute value of 0 minus 2, less than 5. 0 minus 2 is negative 2, so the absolute value of negative 2, is that less than 5? The absolute value of negative 2 is 2, so we get 2 less than 5. That is true. 2 is less than 5. So I will write true on that interval where we got the 0 test value. Let's test our test value of 3. Substituting that in, we get the absolute value of 3 times 3 minus 2. Is that less than 5? The absolute value of 3 times 3 is 9 minus 2, less than 5. 9 minus 2 is 7, so we get the absolute value of 7 is less than 5. Absolute value of 7 is 7. 7 is less than 5. That is false. 7 is not less than 5. So I will write false on the interval where we got the test value of 3. Okay, next we'll shade the true intervals. Okay, so we've got an open circle on our -1. We've got an open circle on our 7/3, and our true interval is in between those two values. And then we will write the solution. So we're looking at this part of our number line. So we've got -1, x is in between, and then 7/3. So we've got, and -1's not included, so it's a less than. 7/3 is not included, so another less than. So our solution in inequality form is -1 is less than x is less than 7/3. In interval notation, we would write smaller number comma larger number, or -1 comma 7/3. -1 has an open circle, it's not included, so it gets a curved parenthesis. 7/3 also has an open circle, it's also not included, it also gets a curved parenthesis. So this is what our solution looks like in interval notation. Okay, let's look at the other form. Here we're going to look at the absolute value of something is greater than a number, or greater than or equal to a number. So for example, the absolute value of -2x plus 1 is greater than or equal to 4. So with this form, the pattern is to remove the absolute value bars and then to write two inequalities with an or. So here we'll have x is less than or equal to, because we have a greater than or equal to, we've got the equal bar here. So x is less than or equal to the opposite of a, or x is greater than or equal to a. So for our example, we'll have -2x plus 1, what was in the absolute value bars, is less than or equal to the opposite of 4, or -2x plus 1 is greater than or equal to 4. Again, I'm going to solve these using test values. And again, we got the -2x plus 1 from inside the absolute value bars. And we took the 4, we've got the positive 1 on the right. I've got the opposite of that over here on the left. So now we will change these two equations and solve for x. So I'll rewrite this as -2x plus 1 equals -4, or -2x plus 1 equals 4. Solving for x, I'm going to subtract 1 from both sides. I get -2x equals -5. Divide both sides by -2. I'll get x equals, the negatives will cancel out, and I'll get x equals positive 5/2. On the other one, I will also subtract 1 from both sides. I'll get -2x equals 3. Divide both sides by -2, and here I'll get x equals -3/2. So again, I'll draw a number line, and I'll plot or graph these solutions. So I've got my number line. Again, -infinity is to the left, positive infinity is to the right. -3/2 is smaller, so it is graphed to the left. It comes from the inequality that has a greater than or equal to symbol. It has the equal bar. It's included, so it gets a closed circle. And then I've got 5/2 to the right because it's a larger value. It comes from this other inequality, which has a less than or equal to symbol, also has the equal bar, so it is also included. It gets a closed circle as well. And then we will choose test values in the intervals, and I see 3 intervals here, and we will test in the original, in the absolute value inequality. To the left of -3/2, I'm choosing -2. In the interval between -3/2 and 5/2, I'm choosing 0. And choose a number greater than 5/2, I'm choosing 3. So on this next slide, we're going to actually choose or test our test values. Let's start by testing -2. So substituting in the absolute value of -2 times the -2 that we're substituting in, plus 1, is that greater than or equal to 4? So -2 times -2 is 4, so we get the absolute value of 4 plus 1 greater than or equal to 4. 4 plus 1 is 5, so we get the absolute value of 5 greater than or equal to 4. Absolute value of 5 is 5, so here we get 5 is greater than or equal to 4. This is true, so I will write true on the interval where we got the test value of -2. Let's test the value of 0. Substituting that in for x, we get the absolute value of -2 times 0 plus 1. Is that greater than or equal to 4? -2 times 0 is 0, so we get the absolute value of 0 plus 1 greater than or equal to 4. 0 plus 1 is 1, so we get the absolute value of 1 greater than or equal to 4. The absolute value of 1 is 1, so we get 1 is greater than or equal to 4. This is false, so I will write false on the interval where we got the test value of 0. Let's test 3. Substituting that in for x, we write absolute value of -2 times 3 plus 1. Is that greater than or equal to 4? -2 times 3 is -6, so we get the absolute value of -6 plus 1 greater than or equal to 4. -6 plus 1 is -5, so we get the absolute value of -5 greater than or equal to 4. The absolute value of -5 is +5, so we get 5 greater than or equal to 4. 5 is greater than or equal to 4, so this is true, and I will write true on that interval where we got the 3 test value. Okay, so next we will shade the intervals where we got true. So we got a true here on the left and a true here on the right. So we've got the -3/2, that's a closed circle, and we'll shade to the left. We've got the 5/2, which is a closed circle, and we'll shade to the right. And then we will write the solution. So on the left, we've got x is less than or equal to -3/2, and we need an or because we have 2 separate pieces. And then on the right, we've got x is greater than or equal to 5/2. In interval notation, remember we always write smaller number comma larger number. So for the left piece, we write -infinity comma -3/2. Infinities always get a curved parenthesis. -3/2 is included. It has a closed circle, so we write a squared off bracket. Or in interval notation is the union symbol. So for the right interval, our smaller number is 5/2. So we write 5/2 comma +infinity. 5/2 has a closed circle, so it's included. We have a squared off bracket, and infinities always get a curved parenthesis. So here we have our solution in both inequality form and interval notation.